Okay, so here is another probe that I use in my classroom, and I use this one at the start of talking about magnetism, because it simply asks, if you've got two kids here talking and they're disagreeing about what magnets pick up. One says, I think magnets pick up anything made of metal. The other one says, I think magnets only pick up some things made of metal. So it's a good pre-test to kind of see what your kids already understand about magnetism. So then, in my classroom, students have usually worked with magnets before, and so they're a little familiar with it, or I'd say pretty familiar with it. So there are some, but you are going to get some AIMS activities that will help kids explore magnetic force. So one of them is called holding power, and in this activity, they are testing, what do you think is stronger? Do you think two magnets together are stronger than two individual magnets? So again, in their notebook, or depending, I often make these my own to fit what I need to teach. So I would have them in their notebook make their prediction of what they think and why they think that. Surely they've all experienced some magnetism at this point. Of course, you can always have them bring in a magnet from home, or find magnets around in your classroom and play with them. But you're also going to have some ring magnets they can play with. So for holding power, this is really simple. You have a chart here. You have paper clips. These are jumbo clips. So we're going to test. We're going to take one magnet. Oh, that's what I got. And it's a quick, because if you let them, and if it falls off, it doesn't count. So if you let them do this, they're going to try to pick up as many as they can. You have to make sure that they know it is simple. Oh, I got them in a chin, no wonder. Sit the magnet down, come up with as many as you can. It's not a try to pick up as many as you can. So then, of course, they pull the magnet up, they take off the paper clips, they count, they record. Then they're going to take a second magnet. They're going to do the same thing. Put their paper clips back in the pile. They're going to take the magnet, quick pick, count, record. Now, in the second part of this activity, then they will put both magnets together, and they will test two magnets. Oops, and I forgot to do the simple thing, but they will pick up, and they'll count and record. So here's what's going to happen. The two magnets together will pick up more than a single magnet. However, they will not pick up as many as the two single magnets together. So they're going to add what they get from each magnet independently. That number will be greater than what they can pick up with two magnets. Why? Let me tell you. When you put the two magnets together, they become one magnetic force. They're no longer operating independently. They become one magnetic piece. So this can lead to questions of, well, what happens if you add more magnets, etc. More ways to expand this. The next activity is tug of war. And in tug of war, you need a ruler, and you're actually putting, you need opposite, tug of war. So they're comparing the push and the pull. And so you're going to, students will have to work together on this, because you need to make sure you have opposites, or same poles facing. And they start at each end, make sure 0, 30, again, this is a great time to review how to read a ruler. But we have to start at 0 if there is a 0 mark. And this, of course, would go here, and then each person would slide. I'm sorry, I'm doing this backwards. You're going to push, and it should. There we go. You're going to measure. These might not be the best magnets for this, but they're going to measure how close can you get the opposite force before this one moves, and vice versa. They will experiment with both the push and the pull, and what they will learn is that the push and the pull are equal. They're equal forces. So one is not greater than the other. That is magnetic tug of war. Now, once you've done both of these activities, they should be asking lots of good questions. So this is the perfect time to implement the design process. Let the kids work together, develop a question they want to answer. How can they pick up an entire box of jumbo paper clips? Or how can they build a repelling force to push a magnet further away? Lots of different questions that they can come up with, and they can design their own test. So again, this is authentic. They are developing the question, they develop the plan for test, they collect data, they analyze it, they share it.